In this video, we're going to be discussing hexadecimal numbers. So let's talk a little bit about why we need to know about hexadecimal numbers as a computer forensics investigator. Sometimes it is necessary to investigate data at the binary number level or raw data level. As you know, everything on a computing device is represented in terms of binary numbers. So when we say binary numbers, basically it's a number system that uses only two symbols, either zeros or ones. Criminals hide or manipulate their data at the binary number level. Therefore, it's necessary as an investigator for us to somehow look at the data in its native format. That is, in numbers. So we can look at the numbers in zeros and ones, but that's probably too much. So that's why they use a more compact way of looking at the data, which is using the hexadecimal numbers, translating the binary numbers into hexadecimal numbers, which compresses the data in terms of its representation. Now let's have a brief review of number systems. Decimal numbers are used for humans. We also call it a base 10 number system because we use 10 symbols from 0 through 9. Binary numbers are used for computers. It uses base 2, meaning it uses only two symbols, 0 and 1, to represent numbers. So how do we then use binary numbers or numbers to represent data? It's done by something called encoding. So for example, let's say we have a letter A and we encode letter A and represent A by a certain combination of binary numbers like 0, 1, 0, 0, 0, 0, 0, 1, like this. So we can always use this pattern 0, 1, 0, 0, 0, 0, 0, 1 to represent A, but for displaying purposes, especially for human consumption, displaying the raw binary data is probably too cumbersome. It takes up a lot of space and it's more difficult to deal with when trying to detect a pattern. If we have a more compact way of representing the same binary number, it will be easier for humans to detect a certain pattern as an investigator. So therefore, this is why we use this hexadecimal representation of data. It's more compact. For example, A was represented by this binary number 0100000001. When you are using a hex number, the same pattern can be represented by number 41. Therefore, it's easier to deal with and better for detecting a pattern when you're using a hex number instead of a binary number. Think about the difference between 0100, 0001 versus 41 or 41. In an encoding system called ASCII, a letter is represented by 8 bits or 8 binary numbers. 8 bits are equivalent to 1 byte. So 8 bits are the same as 1 byte. For example, A was represented by 8 binary numbers 0100, 0001, and then it was then transformed into 41. Once again, to reiterate, in this case 8 binary digits or bits were used to represent this letter A, which is 1 byte, and instead of 8 digits, if you're using a hex number, as you can see in this case, 2 hexadecimal digits were used to represent 1 byte. So this is the power of using a hex number rather than a binary number system to represent a letter when you're doing your encoding. Finally, let's have a brief brush up on hexadecimal number system. It uses base 16, so it has 16 symbols in the number system, starting with 1 all the way through 9, and after that you need special symbols to represent numbers such as 10A, 11B, 12C, 13D, and 14E. F is used to represent 15. So each hex digit is capable of representing 4 binary digits. For example, 1111 is represented by F, 1110 is represented by E, 1101 is represented by D, and so on. And in our previous example, the binary pattern was 0100, so that pattern was represented by number 4, and then 0001 was represented by 1 in hex numbers.